All right, hey guys. Today we're going to talk to you about the physical geography of Australia and Oceania. It's kind of a fun one just because the islands are really beautiful and there's a lot of really cool different geographic um, features and all kinds of really fun things. We're going to talk about the Great Barrier Reef and so a bunch of different types of geographical forms. Buckle up. Here we go. All right, so let's start with Australia. So, Australia is the only place in the world that is a continent and a country. Okay, so it's the only one. It is not an island. So, a lot of people say the largest island in the world is Australia. Technically, it's not an island because it's a continent. So, continents can't be islands. So, they are their own landforms. So, if it may ask you a trivia question, what is the largest island in the world? It's Greenland is the largest island. So there's a lot of mountains and plateaus in Australia. Most of it is pretty flat, but you can see on this here. So there's a dividing line that goes just across. It's basically going right across this line here. Okay, you can see how it goes up and down. But the big thing, the highest level is what's called the Great Dividing Range. Okay, so that's this right here. This is where all the rivers start, or most of them start here, and then they flow out into to the lake or into the ocean from there. Okay, so this is where they get most of their fertile land and that. Um, then there's the Western Plateau. The Western Plateau covers about 2/3 of the continent, so it is extensive. It's like this big here. Okay, and that includes what's known as the outback. So very, very few people live in this area. There's 3 different deserts there, so they include the Great Sandy Desert, the Great Victoria Desert, and the Gibson Deserts, or Gibson Desert. Uh, and then Nullarbor Plain, that sits right here. You can see this little green area here. This is that plain right there. And it's virtually treeless, but it's kind of green. There's no real trees or anything, but then the land, it just kind of just abruptly ends. So this whole part right here is just like straight cliffs going down into the Indian Ocean. And this, you can see, it's called the Great Australian Bight. This right here. And that is part of the Indian Ocean. So all of this is the Indian Ocean that surrounds Australia here, all of this here. Okay? All right. So let's talk about the Great Barrier Reef. So the Great Barrier Reef sits on the northeastern coast of Australia. So it's this right here in this map. And this is a national park and it's a UN World Heritage Site. There's a lot of different types of animals that live there. It's very colorful. There's all kinds of different fish and all kinds of different kinds of animals that live there. Um, but it is a protected area, protected part of the world. So it's actually, the name makes it sound like it's like one big reef, but it's not. It's actually made up of 2,500 smaller reefs who have all come together. So these reefs are made up of coral. So coral, and that's what this is here, these little spots here, all this is coral. So coral is very hard, and there are limestone skeletons of tiny sea animals. And the Great Barrier Reef extends about 1,200 miles. Okay, 1,250 miles. So this right here is a Great Barrier Reef. So I'm going to show you some pictures here of the Great Barrier Reef. So this kind of looks like a fish tank, but this is actually the Great Barrier Reef. And this might look like something out of Finding Nemo because Finding Nemo was it was a part of the Great Barrier Reef. This is one of the issues with the Great Barrier Reef. So this is what it should look like, and in many places this is what it does look like. So there's what's called bleaching of the Great Barrier Reef, and this has been caused by a few different things, but the biggest is what the Australians call cyclones, but what we would call hurricanes. So they come in and basically the hurricanes will warm up the water and it'll get so warm that the coral basically cooks. and it bleaches out and it dies. And so we're seeing this bleaching of the Great Barrier Reef, and it's basically dying off. Okay, so about a third of it right now has died off. So I'm going to show you this video here. It's not very long, but it shows kind of what's being done to combat this.
People come to the Great Barrier Reef and expect doomsday. It has been publicised that the Great Barrier Reef is dead. I can assure you it's definitely not dead. However, the Great Barrier Reef is under threat. There are so many animals that are relying on us. We need to do something, because if we lose all of this, it's going to have a huge impact. My name's Johnny Gaskell and I'm a marine biologist on Daydream Island. We've got Luann here. How you going, Luann?
Oh, pushy.
I guess the first thing we do each day is head into the living reef, check the animals, check the corals, check the water quality. Once we've done that, we invite guests to come with us on educational tours to inspire people to want to protect the oceans through the connections that they make with the animals. The Great Barrier Reef is the largest living structure on the planet. It's a 2,300 kilometre stretch of coral reef. So all of the organisms that make up the Great Barrier Reef are colonies of animals. And these little polyps excrete calcium carbonate and make these structures underneath the soft tissue, and that's how you get your coral structure. The colour in the coral is actually an algae that lives inside the coral tissue, and that's where you get all the bright, vibrant colours. It is very important to note that although some parts of the Great Barrier Reef are still thriving, on the other side there's a lot of parts of the Great Barrier Reef that need help. If something's not done soon, we may lose these places. In 2016 and 2017, there was 2 mass bleaching events, and because it was consecutive, it had a significant impact on the Great Barrier Reef. An estimated 1/3 of the Great Barrier Reef was affected by this, and we did lose a lot of coral. After the 2017 bleaching, we were hit with Tropical Cyclone Debbie, and that cyclone was a Category 4 that basically sat over the Whitsundays for about 30 hours. So we did lose a number of sites in the Whitsundays to cyclone damage. The day I jumped in at Lovers Cove after the cyclone, it was about 4 weeks after the cyclone. I really didn't want to get in because I kind of expected what was there. It was the worst, just having that memory of this underwater city, just with corals everywhere, fish everywhere. It's so harsh that one day you got in and you didn't realise it was your last time. So now I just want to do whatever I can to help it get back to as close as what it was as possible. There's 2 methods of coral propagation that we're using at the moment. Collect coral, put them onto nurseries that we've actually built under the water in the marine park, and then give the corals time in these nurseries to get to a suitable size where we can then plant them back into the damaged sites. The other method that we're trialling here at the moment is to use coral raceways that are actually out of the water. These tubs use raw water that cycles through them to basically replenish whatever's in there. So we actually grab the corals from the wild, put them into the raceways, leave them there in the raw water as it cycles in a controlled environment for 4 to 5 months till they get to that size we need, and then outplant them back into the wild, into the sites where we've had cyclone damage. The advantage of using the raceways is it's controlled, it's right there, we have it in front of us, and if, God forbid, another cyclone comes along, at least then we have the coral fragments ready to go inside these raceways, and the outplanting can be done much faster. So this is a coral raceway. This one here I actually designed late one night, some crazy idea. We're really lucky that the Queensland and Australian government actually funded this project. It's really good to get the support of the government, and without them, none of this would have actually happened. It's the first time this is done in the region, so hopefully in the future other places do the same thing. So this is a pretty exciting moment. We've got the coral raceways up and running, ready to go, and the very first coral is about to go in it. Let's do it. Well, this is it. All right, coral. Wow. Yeah. 8 months of planning, and this is it. The coral's in. This will be one of the species that we will be propagating inside the raceways to then outplant into the wild. We've actually named him. We named him Steve. The longer we leave him in here and the longer he stays healthy, the more we know that this system really works. First coral. Have a look at it. It is thriving. I reckon it's doubled in size already. No. You know what? I actually haven't been in here since the cyclone. This spot. After the corals have spent a bit of time in the raceways, this is potentially one of the sites that we will aim to restore. So I'm going to jump in now with the camera and see if the corals are going to have a happy home. What I just saw down there was clear cyclone damage. There's not much cover on any of the rock surfaces, and the coral rubble as far as you can see. With a little bit of assistance, hopefully this site can come back. People all over the world want to come and see the Great Barrier Reef, but there are actually ways that people can come and help out with the recovery of the reef. The citizen science effort is paramount to this project. We want people to come to the region, go to the sites that we've recovered, take photos, send them to us, upload them, and then hopefully over time we can get an indication of how it's recovered. It's not too late for the Great Barrier Reef. If everybody does their part, then future generations will get to experience all of this.
Okay, so that is kind of some things that they're doing to help with the Great Barrier Reef. One other thing they're doing too is kind of interesting, and they're using sound, doing sound therapy on it. And basically, they have like these hydro speakers that they put around the reef, and they have mimicked sounds that you would normally hear in a healthy reef, and that basically tricks fish into moving into that area. And fish, I don't know if you know this, are very territorial. So once they like live in a spot, they stay there. And so they're like tricking these fish into moving into places, and it's like helping for those places to like repopulate, and it's getting brighter and more healthy in that region of the Great Barrier Reef. So pretty interesting things, and they're definitely doing some good things out there to help to recover it. So, all right, let's talk about Oceania. So Oceania is made up of thousands of different islands. There's all kinds of islands in the South Pacific, basically. Some are made by tectonic movement, and then others are made by volcanic activity. So there's 3 different island groups, and then there's 3 different types of islands. So we'll talk about the 3 island groups first. So you can see on this map here, these are the 3 different island groups. So you have Micronesia, Melanesia, and Polynesia. Okay, so Melanesia means black islands. So that lies to the north and east of Australia. Okay, so that's this here. Oh, I'm sorry, this here. And then Micronesia is just north of that. And then you have Polynesia, which means mini islands. And this goes all the way up, midways up here, all the way down, and includes Hawaii, all the way down into New Zealand. Okay, so all of this here is Polynesia. And so those are the three different areas there. Now, there are three different types of islands. So you have high islands, low islands, and continental islands. So high islands would be islands like Tahiti, for example. So this is where they're larger islands that are usually made from volcanoes, but they have mountain ranges that are split usually by valleys that fan out into more coastal plains, and oftentimes you'll see bodies of fresh water that dot the land, so they can have agriculture on that land. These are more populated type of islands than, let's say, the low islands. So low islands, many of them are called atolls. Okay, and so this picture right here is an example of an atoll. These are ring-shaped islands that are formed by the buildup of coral reefs on the rim of submerged volcanoes. So what that means is that volcanoes had peaked and coral reefs and land started to form around. Okay, and then the volcanoes eventually died out and went back into the water, and so this would be like the opening of the volcano, and then that's where they're at. So they often encircle what are called lagoons. So this right here would be a lagoon. Lagoons are usually shallow pools of clear water. They usually have very little agriculture and almost no natural resources on any of the low islands in general. Okay, even not only just the atolls, but just in general. Continental islands. So this would be example would be like New Guinea or New Caledonia. These are formed by the rising and folding of ancient rock from the ocean floor. So these are actually made from the tectonic plates moving, okay? And so these are usually larger islands that would include volcanoes. They'll have mountains, they'll have plateaus, valleys. Oftentimes they'll even have like rivers sometimes. And they have a lot of natural resources on these islands. So they'll have like mining, so like different things that you would mine, like coal or things like that. They have oil on a lot of them. Timber is huge. Different things like that. So all kinds of different natural resources. So I want to look here. So this is an example of a high island. Okay, so this is actually Tahiti, one of the islands of Tahiti. So you can see it's got the mountain ranges, and then it has the low-lying area, and then it goes into a coastal plain, and that's where the people live. Okay, so that's a high island. This next one is a low island. This one is not an atoll, but this is called Narara. This is an island of Fiji. And this is an example here of a low island. Okay, that's usually created by some kind of volcanic eruption or whatever. So this right here shows how those two different islands are created. Okay, so you see the high island where you have basically the creation of these islands through the magma coming up. You can see the more it boils over, the larger the volcano cones rise, okay? And then that's what creates those mountain ranges. And then this right here is a creation of an atoll. So this is one of these sticking out, okay? And it is, you can see there's a coral reef forming around it, and now it's starting to recede back into the water. It's starting to erode away, and this is what you end up with right here. So this is an example of a low island, or in this case, this is an atoll. All right, and then this right here is a continental island. You can see much bigger. Okay, so these are much bigger islands. A lot of resources on these. Very beautiful, just like the high islands and the low islands. But continental islands are much bigger, much more population on these islands. Okay, so moving on to New Zealand. So this would be another example of a continental island, these two large islands here. So New Zealand is located southeast of Australia, and there are two main islands on New Zealand, but there's other islands that make up New Zealand as well, but there's two big ones. So you have a North Island and then a South Island. So the North Island is the smaller island, and the South Island is the bigger. So in the North Island, the northern region has golden beaches, it has ancient forests and rich soil. And then in the middle, there's a plateau that has hot springs and several active volcanoes. One of these volcanoes is Mount Rapaho. I always mess that up. It's the highest point in New Zealand, Mount Rapaho. Um, in the South Island, there's a lot of different things going on. So there's a mountain range that goes right through the South Island called the Southern Alps, and it runs along the western edge. The highest peak is known as Aorangi. It's named by the Maori people, and so those are the people who are indigenous to New Zealand. And it has all kinds of sparkling lakes that are carved by glaciers. It has rivers. There's all kinds of different types of geographical features. One is the Canterbury Plains, and that's where the most fertile land is. So this is where most of the agriculture happens in New Zealand. But along the western coast, there's all kinds of rugged cliffs, deep fjords, and then coastal caves all along that coast. And then, so this right here, you can see this is the North Island, and then the South Island. You see the Southern Alps kind of goes right through it there. Canterbury Plain, right there. So there's a lot of fertile volcanic soil in New Zealand. So about half of the land actually supports crops and livestock. But there's like a lot of people don't live there, which is kind of weird. But sheep and wool products dominate their exports. Timber is a very large industry. They have all kinds of timber there. Rivers and dams produce abundant hydroelectric power, so they use primarily hydroelectric power, but they also use geothermal energy to get their electricity and things like that. And that is provided by the water that's heated underground by the volcanoes. Okay? All right, well, that's all I got for you today. I hope you guys have a good rest of your day.